This is a recast of the 5,300-word piece, Popular Algorithms and Models in Machine Learning from Shinpat AI. This article discusses the popular algorithms and models used in machine learning and their various applications. Let's listen in.
So, the article is about machine learning, which is a subset of artificial intelligence, and its popular algorithms and models.
Right, and machine learning is really big in the tech world right now. It's been used to solve all sorts of problems across different industries, like image and speech recognition, natural language processing, fraud detection, and predictive analytics.
That's right. And the article discusses the importance of understanding these algorithms and models, which can help you develop powerful applications.
Absolutely. So let's start by talking about one of the most popular algorithms used in machine learning, random forest.
Yes, the random forest algorithm combines multiple decision trees to make more precise predictions. Essentially, each tree in the forest is built using a random set of features and training data, making the model less prone to overfitting.
Right, and when making a prediction, each tree in the forest votes, and the majority vote of those trees is used as the final prediction. So this algorithm is commonly used for classification tasks like predicting customer churn or identifying fraudulent credit card transactions.
That's true. Now, let's move on to supervised learning.
Supervised learning is a widely used technique in machine learning that involves training an algorithm to predict a target output variable based on input data and labeled examples. It's used to classify data accurately.
The goal of supervised learning is to learn the underlying relationship between input and output variables and generalize it for unseen data. Popular algorithms for supervised learning include linear and logistic regression, decision trees, random forests, support vector machines, and neural networks.
Right, so these are all important algorithms that can be applied to different problem domains like healthcare, finance, or gaming. Now let's dive into some of the advantages of supervised learning.
One of the main advantages of supervised learning is its high degree of accuracy in predictions. It also has good scalability since it can process large amounts of input data and generate useful output in a reasonable amount of time. Moreover, supervised learning models are relatively easy to interpret, making them great for understanding how decisions are being made by the model.
That's true if supervised learning models provide great insight for business applications as well as research applications.
Definitely. Now let's discuss some of the limitations of supervised learning.
Supervised learning models require large datasets for training that contain accurate labels for each record. If the training data contains errors or bias, then the model will not be able to learn properly and may produce inaccurate results. Additionally, supervised learning models can be prone to overfitting if there is too little or poor quality training data available. Finally, some supervised learning models require careful selection of features in order to reach optimal performance.
That's all really important points to consider when using these algorithms and models in your machine learning applications.
Absolutely.
Decision trees are easy to understand and interpret, so they're popular for applications like finance, healthcare, and fraud detection. However, they can be prone to overfitting and don't perform well with high-dimensional data.
Then there's linear regression. Linear regression is a basic algorithm used for predicting continuous values in a dataset by building a linear model that accurately represents the relationship between the dependent and independent variables. It's simple and effective, and it's often used as a starting point for more complex models.
That's right. Logistic regression is another popular regression-based binary classification method for modeling probabilities with binary-dependent variables. It's widely used in machine learning and is particularly useful when the outcome variable is binary and the independent variables are linearly related.
Random forests are an ensemble learning technique that uses multiple decision trees with random samples of the data set and random subsets of features as inputs. It helps to overcome overfitting and the curse of dimensionality by only considering a subset of variables.
Finally, there's support vector machines, or SVMs. This algorithm looks for the optimal hyperplane that separates data points into different classes using a kernel function to transform the data into a higher dimensional space. SVMs are great for complex datasets with high variance and nonlinearity, and they are commonly used for classification and regression tasks.
That's not all though. There's also neural networks and unsupervised learning. Neural networks are interconnected systems of nodes that are modeled after the human brain's functioning, and they can be used for tasks like image recognition, natural language processing, and speech recognition. Unsupervised learning algorithms analyze data without any prior knowledge or labeled data, and they're used to identify patterns, features, and group data points based on similarities.
That's right, and there are some popular algorithms and models used in unsupervised learning. For example, there's k-means clustering, which is a well-known algorithm used to cluster data into k-groups based on similarity measures.
Then there's also hierarchical clustering, which creates clusters by recursively merging smaller clusters based on similarity scores. It's useful for exploring the structure of the data and identifying natural groupings, but can be computationally intensive for large datasets.
Other unsupervised learning algorithms include principal component analysis, PCA, and independent component analysis, ICA. PCA is a technique used for dimensionality reduction and is central to ML. It deals with large sets of data and identifies correlations to form a smaller set of uncorrelated variables. ICA is a statistical signal processing technique that is used to decompose a multivariate signal into independent, non-Gaussian components.
There's also association rule learning, which is a technique used to discover associations or relationships between data items. It's mainly used in market basket analysis, where it is used to identify which products are purchased together or are used in combination most often.
And finally, there's the random forest algorithm, which is a highly popular approach in machine learning due to its abilities in classification, regression, and outlier detection tasks. It is an ensemble learning method that combines multiple decision trees, where each tree is trained on a random subset of the input data and features.
In this article, we're focusing on reinforcement learning, which is a type of machine learning that enables an agent to learn through interaction with an environment by receiving rewards or punishments for its actions.
Reinforcement learning enables an agent to find the optimal solution to a problem through trial and error. This process is achieved by training an agent on a policy that maximizes a reward function.
RL finds its application in various fields, including robotics, game playing, and autonomous systems. Because of its effective use in decision-making processes, it is becoming increasingly popular in many areas.
There are different algorithms and models used in reinforcement learning, including Q-learning, SARSA, and Deep Q networks, DQNs.
Q-learning is a model-free method that trains an agent to learn an optimal action value function that maximizes the rewards obtained during interactions with the environment. SARSA is a similar model-free approach that focuses on policy learning, in which the agent follows a policy that leads to the optimal state action values.
DQNs are a type of deep reinforcement learning algorithms that use a neural network to approximate the Q value function. They have been successful in demonstrating complex learning abilities in tough environments.
Another area of reinforcement learning is deep reinforcement learning, which combines deep learning and reinforcement learning. This can be used to advance our ability to create intelligent machines that can learn and make decisions in complex environments.
Then there's Monte Carlo Tree Search, MCTS, which is another search algorithm that employs a decision-making process based on random selection of nodes in a tree structure. It's great for complex problems where perfect information is unavailable and the outcome of an action cannot be predicted with certainty.
Lastly, there are policy gradient methods, which directly optimize the policy function, which specifies the probability distribution over actions given a state. Reinforce, actor-critic, and proximal policy optimization are some of the most common examples of policy gradient methods.
So now that we've gone over the different algorithms and models used in machine learning, let's talk about some specific examples of their application. The convolutional neural network, CNN, is a widely used model for image and video recognition tasks. Generative adversarial networks, GANs, are used for generating new data and images. Recurrent neural networks, RNNs, are ideal for analyzing time, series data, and natural language processing tasks.
And in terms of artificial neural networks, they can be used for a variety of tasks like image recognition and natural language processing. They are, however, complex and time-consuming to construct, so careful consideration should be taken when designing an ANN.
Now let's talk about deep belief networks, DBNs. DBNs are a type of artificial neural network that consists of multiple layers of hidden units. They are used for tasks such as image recognition and recommendation systems and can be trained using unsupervised learning.
Lastly, let's talk about generative adversarial networks, GANs. GANs are a powerful technique in machine learning that are used for generating new data. A GAN consists of two neural networks, a generator that generates the data and a discriminator that determines if the generated data is real or fake. GANs are widely used for image and video generation, but they can also be applied to other domains such as speech and text generation.
So as you can see, machine learning algorithms and models are incredibly powerful tools that can be used for a variety of tasks. With their ability to recognize patterns and make predictions, they have applications in fields such as image and speech recognition, natural language processing, and autonomous driving.
We hope this discussion has given you a better understanding of the popular algorithms and models used in machine learning and their various applications.